This is Josh White with JW Math Tutoring. In today's video, I'm going to cover the Digital SAT Practice Test number 2, the Math section, Module 2B, which is the harder of the two second modules you would get when you're taking this test in the Bluebook app. So let's go ahead and get started.
But life is a dream that calculus could never predict.
All right, just ready to begin the second module from Practice Test 2, the math section in the Bluebook app. This is the harder of the two second modules. Of course, I had a video going through the easier of the the two second modules, so do be sure to check that out. And just remember that the time for this will most likely be over the allotted time for this section, 35 minutes, just because I like to show multiple ways that you can solve a lot of these problems. And so, for example, on this first problem, you have a system of equations and they're asking for the solution to it. So if you notice, the first equation technically can just easily be solved for x by dividing by 3, so that x is equal to 4. Now, if you plug that into the second equation, you have negative 3 times 4 plus y equals negative 6. You go ahead, you solve that out. You get y equal to positive 6. So we have the correct answer here as letter B. Now, of course, you could just as easily do this on the Desmos calculator. So let me just show you how to do that. First, clear the screen. So all we gotta do is just type in both equations. We do not have to rearrange them in any way. Okay, expand this out. And now we just look for the intersection point. Okay, it's right here, 4 comma 6. What's the y value of this solution? 6, correct answer. Much quicker, much easier than actually doing it out by hand. Okay, next up, question 2. This is a very, very easy basic question. We're just combining two like terms, just subtracting these two monomials. So we just have 11 minus 5 is 6, x cubed. So correct answer here is just going to be letter B. For number 3, here you have an equation and they want to know how many solutions it has. So notice you have the same exact expressions on both sides here. And if you try to subtract 66x on both sides, you would get 0 equals 0. Therefore, this is infinite solutions. Okay? Because we get the same expression or the same number on both sides of the equation. That just means whatever value you plug in, it's going to work. All right, now for this next question, number 4, we have 3 times as many people voting for a proposal as compared to voting against it. And then we also know that 15,000 more people voted in favor of the proposal than voted against it. And they want to know how many total people just voted against the proposal. So first, I'll just show you how you would technically do this by hand and the way you would set it up, kind of with two different equations. So you could basically say 3 times as many people voted in favor of a proposal as voted against it. So technically, if I write this equation, 3x equals y, this is the number of people in favor of it, and this is the number of people opposed. Because when you look at this equation, you notice y is the larger number. Say x is 5, 3 times 5, 15. Okay, 15 is obviously larger than the 5. So the y, the larger number, that's the number of people in favor. X, the smaller number, that's the people opposed to it. All right, now we also know that 15,000 more people voted in favor than voted against it. So the number of people that voted in favor is 15,000 more than the number of people that voted against it. Now that you have this, you could go ahead and solve this. Since they're both equal to y, you could just set, 3x equal to 15,000 plus x, 2x equals 15,000, x equals 7,500. So that's the number of people opposed or against, and that's just the correct answer. So letter A. Now, a couple things just to show you. First of all, once you get the two equations, of course, you could just go to Desmos and you could just type them both in. So we had the 3x equals y, and we also had the y equals 15,000 plus x. Now the problem is you're gonna have to zoom way out. Keep zooming out to see where these things intersect. Because let's see here, what's the problem? It's graphing one of them, but it's not graphing the other one. Possibly because it's written like this. The numbers are too large. Why is it not graphing it? There, oh, that's the issue. Don't put the comment. Okay. So now that I zoomed out a bunch, okay, I can see where they intersect. 7,500 and 22,500. So x is the number of people against. That's 7,500 for the coordinate. So you could solve this system of equations, again, by graphing it, finding the intersection point, and whatever, get it from that. Now, an alternate way you could do this is by using back solving. So actually, we'll bring up the calculator. So you could say, all right, start with answer choice A. How many people voted against it? Okay, 7,500. They tell us then 15,000 more people voted in favor than voted against. Okay, so we have 7,500 plus 15,000. All right, 22,500 people total. Now, they also tell us um, sorry, 22,500 is the total number of people voting in favor of it. 15,000 more people voted in favor than voted against. 7,500 against, add 15,000, 22,500 in favor. Then what you would check is the first condition. 3 times as many people voted in favor as voted against. So when I take 22500 and I divide that, the favor divided by the number against, does it equal 3? Yes. That confirms that A is the correct answer. Basically what I'm doing here is I'm back solving this. So just to show you, I'm not going to go through all of them, but just to show you an example of how the other answers don't work, let's say the people against it was 15,000, okay? Add 15,000 more to that to get the total number in favor, 30,000, okay? Take 30,000, divide that, that's the in favor, divide that by the number opposed. Is it 3 times as many people? No, it's 2 times as many people. So that's wrong. And you could check the others as well. So that's an alternate approach you could take to this, basically back solving it instead of actually setting up the system of equations. All right, now question number 5. Here we have a function that you're given, and they want to know basically what's the best interpretation of this y-intercept value of 30. So your y-intercept, of course, with a linear function is always like the starting or the initial amount. And this is how much juice, this function is telling you how much juice is remaining after he's made X popsicles. So the starting amount would be equivalent to, X equals 0. That's what we know about the y-intercept. So when X is 0, i.e. the number of popsicles made is 0, when he started, that means he had 30 fluid ounces of this juice. So the correct answer is just going to be letter C. All right, next up in number 6, we have one of the student-produced response, grid-in ones, and you're just converting an angle here from radians to degrees. So you do have to know basically the conversion factor, which is that pi radians is equal to 180 degrees. And now this you could obviously do just in the decimals calculator. Notice the pi's cancel out. Turns out 15 goes into 180 12 times, and 16 times 12 is just 192. So the correct answer for this problem is just 192. That's all you put in. You don't put in the degree symbol or anything else. And that's it. All right, here we have a system of linear inequalities, basically with two variables. So there are multiple ways you could do this. So the longer way would be to take each point and plug it in to both inequalities and confirm that it works in both. Okay? However, it is going to be so much easier to do this on Desmos and the graphing calculator, which I'll show you in a second. So I already know, because I've gone through this, the correct answer is going to be letter D. And if you just plug that in, you can see for the first one, you get 0 less than or equal to 14 plus 7, or in other words, 0 is less than or equal to 21, correct. And then for the second one, you've got 0 greater than or equal to negative 2 times 14 minus 1. 0 is greater than or equal to negative 29. So that checks as well. So this point right here satisfies both of these inequalities, therefore it is a solution to them. All right, so now with that being said, let me go ahead and show you how much quicker and easier it is to do this in Desmos compared to by hand. So here we have the first inequality, and technically you can put here, we can put in the less than or equal to so that the border is solid, and greater than or equal to just from the keyboard below. All right, so now we can zoom in because the points we're dealing with are much smaller. So you can see the right side um, is where these graphs is a solution set, where the two shadings overlap, okay? This area on the right. So negative 14, 0, where is that point? Well, it's like somewhere, over here. Is that in the solution set? No. 0, negative 14. Start at 0, go down, whatever. It's going to be like probably down right around here. Is that in the solution set? Nope. 0, 14, start at 0, go up. Is that in the solution set? No. And you can zoom in further. I'm still zoomed out pretty far, but you can zoom in further just to confirm this. The last one, 14, 0, go to the right by some, stay on the x-intercept. Yes, that one is in the shading where it's overlapped. Therefore, that will be the correct answer. Next up, problem number 8. Here you have a right triangle, and they give you the lengths of two of the sides. And they want to know basically what the length of the third side or the hypotenuse is. But technically, they're asking for what the value under the radical is once you get the answer and simplify it. So in other words, we're going to use Pythagorean theorem, and we're basically going to do 24 squared plus 21 squared equals c squared. And when you go ahead, square these both out, add them all up, it comes out to 1017. And then you square root both sides. So c is equal to the square root of 1017. Now, the problem is you have to simplify this. So this might take a little time just on the calculator to figure out what a factor of 1017 is. If you notice the digits 1 plus 1 is 2 plus 7 is 9 add up to a number that's divisible by 3. So 3 is a factor right off the bat, and then you could go from there. I happen to know that 1017 is 9 times 113. And then notice that the 9, square root of 9, goes outside as a 3, and so 113 is what you're left with. So the correct answer for this problem is 113. Another thing to notice is once you get down to this step, okay, and you have the 1017 under the radical, basically The answer has a 3 in front of it, so that's a clue or that's a hint that there's a factor of 9 on the inside number before it gets simplified. So that's how you could also tell that there's at least a factor of 9 somewhere in the 1017 that you'd be able to, simplify out to the 3 outside. All right, next problem we have here is number 9. So here you have two basically frequency tables for two different sets of data. They have the same values, but the frequency of the values is different for each of them. And they want to compare the means of the two data sets. Okay, so the first thing is theoretically, um, you can look at the frequencies that occur for each value and determine that the mean of data set A is going to be greater than the mean of data set B, or the average. Um, the reason is because if you look at how the values are distributed, A has a lot more values for larger numbers. 46 appears 9 times, 42 appears 7 times, and so on. Whereas B is set up so that the numbers that appear most frequently are the smaller values, like 30 and 34. So if you're just going to do like a dot plot, for example, of these, and you had 30, 34, 38, 42, 46, A would have a bunch of dots over here, and then a couple less here, and then a couple more, you know, blah blah. And then if you went to B, instead B would have all of its dot, a lot more dots down here at 30, and then a lot more down here at 34, and then here, and then get smaller as it goes to the right. So just by looking at that, you can figure out that the correct answer for this is going to be A. The mean of A is going to be greater. However, if you don't recognize that or you're not convinced of that, you can just go to Desmos and quickly and easily calculate the mean for each of the sets, and then you'll see that A is bigger than B. Okay, so the way we're going to do that is going to create a new table. Expand this a little bit. All right, and what I need to do is enter in the um, values in the X1 column. All right, and then the Y1 column is going to be the frequency. So this is for data set A. Now, I'm just going to type down here expression. It's basically taking the total of x1 times y1. So in other words, it's multiplying the x1 value times the y1 value, and then at total just summing them all up, adding them all up. So all these values together from data set A add up to 1094, and then we divide by the total number of values, which is 27 for each. So for A, we can see that the mean is going to be 40.52. Let's just like whatever, round it off. Okay, so 40.52. Now we'll go ahead and calculate the same thing for B. So I can leave the x1 columns the same because that is because the values are the same. It's just the um, frequencies, the y ones, that I have to change. All right, so notice when I just update those to the new values for B, keep everything else the same, now the mean comes out to 35.48. So we can clearly see that the mean of data set A is greater than the mean of data set B. And again, you can just go to Desmos, make a table, put in the values one column, the frequency in the other column, and then underneath that, you do total x1 times y1 and divide that by the total number of items. All right, so this just again confirms that the correct answer is going to be letter A for this problem. All right, next up, number 10, we have two similar triangles. So basically, all you're going to need to know for this problem is which angles correspond to each other. The fact that they tell you that 2xy equals rs, like that's actually irrelevant. That has nothing to do with the problem. So if you just draw, a quick picture here, rst, and then we draw another picture and we match up the angles. So x is first, that corresponds to r, y is second, that corresponds to s, z is third, that corresponds to t. Okay. Angle z is 20 degrees. what's the measure of angle t? So since z corresponds to t, and these are similar triangles, it will have the same angle measure. Therefore, correct answer is 20 degrees, and that's it. This piece of information right here, completely irrelevant to this question. It tells you what the scale factor is, but you don't need the scale factor. You're only asking about matching up, basically, a pair of corresponding angles, which will have the same measure. All right, next we have a basically a linear function here. And notice that the 32 that these two expressions are equal to right here, this represents total number of like cups of something, cups of broth. And they want to know what 5y represents. So basically, if the number on the right is cups, of broth. So the 5y has to also represent total number of cups of broth. Question is, so we can get rid of this, we can get rid of this, because it already tells us in the problem, x is the number of small jars, y is the number of large jars. Okay, so expression is not going to be the number of jars. Those are just x and just y. So now is the total number of cups, is it from large or small? Well, we know y is large jars, so we multiply that um, by 5. That's going to be the total number of cups we get per large jar. Correct answer to this one is letter C. All right, on question number 12, we have another basically fill in the blank student Bruce response question. And they want to know what the sum of solutions to this equation is. So there are multiple ways that you could do this. All right, so first way, you want to do it by hand, you could just go ahead, multiply everything out. X squared plus x minus 56, and on the right side, 4x squared minus 28x. And then get everything equal to 0. I'm going to move everything over to the right so that the x squared term is positive. So that gives me 3x squared. Subtracting it over gives me negative 29x, and then adding 56. Whoops. All right, and now that's equal to 0. So now you have a quadratic function. Okay, so at this point, there are two ways you could do this. The quickest and shortest and easiest way is to know that the sum of the roots or sum of solutions is equal to the shortcut formula negative b over a. So you could do the opposite of negative 29 over 3. That comes out to 29 over 3. You can input that answer, or you could also fill in 9.666 until it doesn't let you type anymore. So up here, like I said, you could put 29 over 3, or you could put 9. Basically it's going to stop, right there. You could also put it in as 9.667. You could round it as well if you wanted to. So I'll just write that down. So either of these three numbers is what you could put as the correct answer. Now, if you don't know that formula, what you could do is you could factor this, 3x and x, and then the factors of 56 are going to be negative 8 and negative 7. So then when you solve it, you get positive 7 as one answer and positive 8/3 as the other answer. And then you just have to add them together. And you could go to Desmos and do that, whatever, do it by hand. It's basically going to be 7 and then multiply by 3 over 3, add to 8/3. So it's 21/3 plus 8/3, 29/3, same exact answer I got. Or, of course, you could also graph this out to try to get the answers that way. The problem is you have to be careful since the answers are not integers. So what I mean by that is we go to Desmos. Okay, so we can see right here our two intersection points we have. So we have 7, and then this one, notice it's 2.667, so it is actually rounded nicely for us to the same number of decimal places that we would input here. So you just look at the graph, add these two values together, 9.667, and that's your answer right there. and then you could be done. So that's probably quicker than factoring, maybe or maybe not quicker than knowing the sum of the solutions shortcut, but that's an alternate way you could just get the two values once you've gone ahead and multiplied it all out. Okay, for number 13, here you have a quadratic function or parabola, and they want to know the interpretation of the vertex. So notice the vertex value here, because this is in basically vertex form, a times x minus h quantity squared plus k. So the h value here is positive 7, k value is positive 3. The x values here represent seconds. So 7 represents seconds and 3 represents its height. Um, does it tell? Oh, it's in, let's see here, inches. So the vertex always in a quadratic equation occurs where a quadratic function occurs at the maximum or minimum point. It will be the minimum point for this one because notice the a value of 1/9 is greater than 0. Therefore, this quadratic function, if you graphed it out, is opening up. So it's going to look something like this. And right here is our vertex. Basically, it's 7 comma 3. So uh, this k value is the minimum, would be the minimum value because the y or the k value or the y coordinate always represents your maximum or minimum value. The x coordinate or the h value represents where it occurs. So when we go through these answer choices, we can see it's going to be A. The minimum height, the minimum value occurred uh, at the time of 7 seconds, but the actual value for it was 3 inches, above the ground right here. B does not make sense because 7 again corresponds to seconds. And all this stuff about starting moving, that's like what the value, those would be values which you plug in 0 for x and then work it out and simplify it. And none of those are correct. Those don't have anything to do with the vertex. So correct answer for this one's letter A. All right, now for this next one, number 14, here we have a function. Technically, it's a linear function, and they want to know, okay, if you increase this temperature by, or basically the x value by 2.1, how much does the overall Fahrenheit temperature increase by? So a couple different ways you could do this. You could notice that technically, like if you multiply this out, it's 9/5 x minus whatever 9/5 times 273.15 plus 32 is, okay? So this 9/5, this is the slope. In other words, this is the change in per 1 unit change in the x value. So now we're going to have a change or an increase specifically of 2.1 units or 2.1 kelvins. So really you're just taking 9/5 and multiplying it by 2.1. And when you do that, it comes out to 3.78. So in other words, you increase the temperature by 2.1 degrees, 2.1 kelvins. The Fahrenheit temperature is going to increase by 3.78 degrees Fahrenheit. So the correct answer is going to be letter A. Now, if you do not see that, like if that's not intuitive to you to figure out, then what we can do is instead we can just plug in some values which are separated by 2.1 degrees and see, well, how much did it go up by? So let's go to Desmos and do that. So this is basically the strategy, the idea of picking numbers. Okay, so first I'm going to say it goes from 0 degrees to 2.1 degrees. Okay, so first I will do it at 0. All right, so I get that value. Then I'm going to do it at, now let's say it went up to 2.1, so this is an increase of 2.1 degrees. And now I just need to find, how much did it increase by? So we got negative 455.89. That's how much it went up to, minus the original temperature, negative 459.67. Okay, it went up by 3.78 degrees, subtracting them. Therefore, it's correct answer A. So again, this is picking numbers. I'm just picking two values for x that are separated by 2.1 degrees to represent that increase, and then subtracting them to find the difference to see how much it went up by. And that confirms again, it's answer choice A. Next, on number 15, here we have a table which has 2 points on a linear function or line, and it also tells us, it also gives us the value for the y-intercept here, at least in terms of, k and whatever b. And it wants to know what the value for the y-intercept is, specifically the y-coordinate of it, of course. So a couple things. Um, when you're looking at this problem, uh, the easiest way that I think to do is just to find the slope between these 2 points. And so if you just go to the slope formula, y2 minus y1, x2 minus x1. So I subtracted negative 15 minus 13, and then k plus 7 minus k. And what's going to happen is in the denominator, the k's will cancel out. Numerator, you get negative 28, and you just get positive 7. So the slope of this line turns out to be negative 4. Okay, so now that we have the slope, the way we can figure out what the y-intercept value is going to basically be kind of thinking about this backwards or in reverse. So what I mean by that is, notice here you have a point k13, right? And the slope of this line is negative 4, 1. So that means if you move to the right, you would go, down 4, right 1. Or if you move to the left, you would go up 4, left 1. Okay? Now, the y-intercept is at k minus 5, comma b. That means the y-intercept occurs 5 units to the left of this value right here because you're subtracting 5 from it, i.e. move 5 to the left. So if I so basically, to move 5 units to the left, I would have to go up 4 5 times. Basically, it's like up 4, left 1, up 4, left 1, up 4, left 1, up 4, left 1, up 4, left 1. And eventually, I will have moved a total of 5 units to the left, which would put me at k minus 5. And since I went up 5 times, I do 5 times 4, and that's 20. Notice that this starting point here of k comma 13 is uh, has a y-coordinate of 13. So if I went up 20 units, that comes out to 33. So in other words, I started here at 13, I went up, up 4, up 4, up 4, up 4, up 4. So I add 20 to that, so I get to 33. So the value for B is going to be 33. Correct answer for this problem is going to be 33. Now, I want to show you an alternate way you could figure this out. It's essentially the same work, but it's if you recognize something earlier when you're solving it, it can actually make it a lot easier. So here's the thing. The y-intercept of a function always occurs where the x-coordinate is equal to 0. So what that means is if you recognize that, that means that k minus 5 has to equal 0. Or in other words, k has to equal 5. So if you just go ahead and plug that in, so we have the points 5, 13, and 5 plus 7, which is 12, negative 15. So we want to know what the y-intercept is. So all you have to do now, and so you could do this by hand, and if you do it, again, you're going to get the same slope value, which is negative 4. But then you could go to y equals mx plus b, and you could just pick one of these points to plug in. So let's say 13, slope negative 4, x value 5 plus b. 13 equals negative 20 plus b. B equals 33. Okay. And you could get it that way. Or the quicker, easier way, of course, is, go to Desmos, add a table, put in the 2 points, and then then we can go ahead and get the equation for the line. Okay, and notice it graphs the line. So all we have to do, you can see right here, it gives you the b value, 33. That's it. That's the answer. But if you just want to look at it and double check right here, it is 0.33. So you can get the answer that way, and that is much quicker, much easier. But you do have to recognize or remember that the y-intercept will always have an x-coordinate of 0. and that will allow you to determine that k equals 5, and therefore you can figure out what these specific points are. All right, next up, question number 16. So in this one, they give you a polynomial with 5 terms and, sorry, with 3 terms, excuse me. And then they give you this other polynomial, 2 terms, and they want to know what the smallest possible value of b is. And they tell you that b is a factor of this. So, okay, a couple things. First, what I would do is I would factor this by pulling out a common factor of 2x, and that's going to leave me with x squared plus 21x plus 104. And then you could go ahead and factor the inside, and it's going to be x plus 13, x plus 8. Okay, so now for the x plus b things, they're looking at these two, factors in here, not the common factor. So what is the smallest possible value of b? Well, it's going to be 8. Now, an alternate way you could do this is you could go to Desmos and you could just graph out the whole thing. Okay, so here, let's scroll down. So let's see. So here's the thing, though, that you have to remember or be careful with if you're doing this in Desmos. So first of all, these are the actual like roots or solutions here. We've got -13, -8, and 0. Okay, 0 is not going to be a possibility because it tells us here that b is a positive constant. 0 is not positive, so we can eliminate that. Then you're down to -8 or -13. Remember though, these are like the zeros, the roots, or the solutions. So these are the opposite values of what would actually be in the factor, right? In other words, if you set this equal to 0 and you solved it, you would get x equals -13 and -8. But you have to remember that here, the b value they're asking for is not the root, not the solution, it's the factor. So therefore, you have to remember that the -8 technically means you factor it as x plus 8, and the -13 means you factor it as x plus 13. Okay, so again, you can do this in Desmos if you're having difficulty factoring it, but just remember that you're going to actually want the opposite of the values you see here. In other words, the b values are going to potentially be +13 and +8. All right, next up for question 17, here we have a linear function, again, another line, and they just want to know what the x-intercept value is. This is actually a very easy, simple question. So we can just set this equal to 0 because at x-intercepts, the y value is 0, and you can solve it for x. And 7x will equal 84, and then just divide by 7, x will equal 12, so the point will be 12 comma 0. Of course, so correct answer, letter D. Of course, you could also go to the Desmos calculator and you could just graph this line out and you could see where's the x-intercept. Oh, right here, 12 comma 0. That's your answer. No more work is needed. All right, question 18. This park has this area in square yards and they want to convert it to square miles. So all you have to do is basically take this, which is in say like square yards. Here, I'm just going to write it as yards squared. And you multiply it by the conversion factor, which is 1,760 yards per 1 mile. But what you have to remember is uh, the conversion factor is linear or one dimension, but the value you're starting with is an area or 2 dimensions. So that means you need to either square this conversion factor or you need to write it twice, however you want to think about it or however you want to do it. The whole point is you have to take this 11 million, number and divide it by 1760 twice in order for the square yards to cancel out and get square miles. So that we just go ahead, we do it in Desmos, it comes out to 3.83, approximately. Correct answer for this one's going to be letter B. All right, next up, number 19. Um, you're told about this gallon of paint, which will cover 220 square feet. This room has a total wall area of W, and they want to know which equation represents the total amount of paint you'll need to paint the walls of this room twice. Okay, so the easiest way I think to attack this one, think about theoretically, is just to do picking numbers. So let's just say that this room has 220 square feet in it. Okay, so in other words, W is 220. So to paint it twice, that means we're going to need to cover 440 square feet, i.e., we're going to need 2 gallons of paint. So now when we go to the answer choices, I plug in 220 for W and I go through them and I see which of these formulas gives me two just as my answer, or for P, my number of gallons. So 220 divided by 110, that is 2, so we keep that one. 440 divided by 2, that is 880. Ignore that. Here, 220 divided by 220 is 1. Ignore that. Last one, 220 times, actually, sorry, I messed up on B. B should be um, 440 times 220, which is obviously not 2. It's some gigantic number, but it's wrong. And then the last one, 220 times 220. Okay, that's 220 squared. That's obviously not going to be correct either. So the correct answer is basically letter A. So just to talk about it briefly from a theory perspective, basically the way you would normally do this is you would take the number of square feet and you would divide it by 220, and that would give you how many gallons you need. But because you're doing it twice, technically you multiply it by 2, and because you're painting it twice, the total area you're actually covering would be 2W, not just W. And then the 2 and the 220 reduced to 110. That's why it's technically W divided by 110. So correct answer is going to be, again, letter A. All right, for 20, here we have a system of equations. And for this one, they want to know, if there's no solution, what does the value of R have to be? So a couple things. What I did is I went ahead and I got all the x. I put this in basically in standard form. I got all the x terms and the y terms and everything on the same side. So for the top one, that's going to be 48x minus 102y equals 24. And for the bottom one, it's going to be 16x plus ry equals 1/6. Okay, now for two equations to have no solution, that basically means they have the same slope, but they have different y-intercepts. Or in terms of looking at their equations in standard form, what that really means is we need the same multipliers for the x and the y values, but a different multiplier on the number terms on the right. So if you look at this, the multiplier for the x's is basically 3. Okay, notice 16 times 3 would be 48. So that means we need the same multiplier here in order for it to match. Okay, so that means we need r to be multiplied by 3 and that overall result to equal negative 102. So you just set up an equation. 3 times r times 3, or 3 times r, equals negative 102, and then just divide. So r comes out to be negative 34. That's what the correct answer is going to be. And then you can just confirm that it's going to be no solution, because on the right, the multiplier here is going to be basically whatever 24 times 6 is. It's going to be some gigantic number. It's not going to be negative 34 is the point, in order to get from 1/6 to 24. And just to confirm, we could go to Desmos. We could graph these two things. Now, for Desmos purposes, we don't have to rearrange the equations. We can just graph them as given. Now I put this R value in here, but what I want to do is actually plug in the negative 34 now. Okay. So the thing is, when I was zoomed out there, it looked like the same line almost on top of each other, but you have to zoom in and you can see very carefully that they are not the same line. They are parallel. They will never intersect, and that's what we want. That's the no solution case. Next up, question number 21. This is a fairly tricky question, although there are actually multiple ways that you can solve it. So first, I'll go through what would be the traditional, algebra way. So if you find this too complicated or just want to see how you can solve it using other methods, specifically using Desmos, that feel free to go ahead, just fast forward in the video. So all we have to do is basically go ahead and solve this equation for x in terms of c. So there's multiple ways you can do that. One way I would do that is I would go ahead and I would subtract this term over to the other side. So we get x squared minus c squared. And they all go over the square root of x squared minus c squared because notice if you subtract it over, they have the same denominator. Okay? And then that's just going to be equal to 39. So now, in order to solve this for x, what we need to do is we need to go ahead and basically get rid of the radical. So the way we can do that is we can go ahead and we can square both sides. So on the left side, on the top, we would have x squared minus c squared quantity squared. On the bottom, the squared and the square root, kind of cancel out. You're just left with x squared minus c squared. On the right side, you have 39 squared. Now here, notice one of the x squared minus c squareds will cancel out on the top with what's on the bottom. So in other words, this cancels out, and you're just left with now x squared minus c squared equals 39 squared. And now you can just go ahead, add c squared to both sides. X squared is equal to c squared plus 39 squared. And now you can just square root both sides to solve for x. Remember to put in the plus or minus. Now when we're looking at the answer choices, okay, obviously it's not A, it's not just negative C. It's not B because B doesn't have a radical in it. And notice for C, it has a minus between the two terms, but here when we solved it, we got a plus between the two terms, so it's obviously not that. It's D, and it's technically the negative of the two. There's a positive radical and a negative in front of the radical, and it wants the negative one. So the correct answer to this one is D. That's how you could solve this, again, using like kind of the straightforward algebra technique. It's actually not, I guess, that difficult or that long, but it does involve, a fair amount of work. Okay, so now let's see other methods you could use to solve it. So one method you could use is back solving. By that, I mean we could take the answer choices and plug them in and see if we get the same expression on both sides. So um, if you go through and you check A, and you plug in negative c for all of the x squareds. So in other words, you set let x equal negative c. Well, then x squared is just going to equal positive c squared, positive c squared, because the two negatives are going to cancel. So basically, you're going to get c squared over square root c squared minus c squared, and same thing on the right, except in the denominators, c squared minus c squared is 0. You cannot divide by 0, so that makes this not a solution. To check B, I mean, basically, this is going to become extremely messy and extremely complicated because if you go ahead and square this, you're going to have negative c squared minus 39 squared, the whole thing squared. So you would like put that in every place where you see an x. And I mean, after fooling with it for a little bit, hopefully you're going to realize that it doesn't match. So in other words, the left side is not going to be squared, okay, over square root. And then again, negative c squared minus 39 squared quantity squared minus c squared. Okay, and on the right side, equal to, sorry, c squared over, again, you got the whole thing, negative c squared minus 39 squared, quantity minus c squared plus 39. I mean, you can spend time fooling around with this, manipulating it, but it's basically clearly not going to be equal to each other. Now, if you look at the last two, basically notice that if these are the x values, then when you square them, the radical is just going to disappear. And of course, they're also both going to be positive. So you really have 39 squared minus c squared, and you could say c squared plus 39 squared to plug in. So if you start with c and you go ahead and plug it in, 39 squared minus c squared, and then underneath the radical, you've got 39 squared minus c squared minus c squared. Then the right side, you got the exact same thing, 39 squared minus c squared minus c squared. On the top here, just c squared, and then you've got a plus, 39 or whatever. So now, basically, the minus c squared would be minus 2c squared minus 2c squared here. And then again, you could subtract these over and you could uh, combine them on the top. So you would technically get 39 minus 2c squared over square root 39 squared minus 2c squared equal to 39. And you should basically, what you can realize is that these two sides are not going to equal. The number on the left could be 39 if c is 0, but if c is not 0, then it is most likely not going to be 39. And you could pick a value for c and plug it in just to test that and confirm it. Now, for the last one, just to show you, if you plug in c squared plus 39 squared over, and then what's going to happen is on the bottom, it's the c squared plus 39 squared minus c squared. The c squared is going to cancel out inside the radical, and that's what's going to make it much easier to simplify, and then you'll be able to easily see that the expressions on both sides are equal. So notice here, c squared cancels, c squared cancels. So then you're left with square root of 39 squared, which is just 39. So now you can subtract over this term to the left. So in the numerator, you've got c squared plus 39 squared minus c squared, and then root 39 squared, which again I said is just 39. Okay, and that's equal to 39. Now notice the c squareds cancel out. On the left, we have 39 squared over 39, which is just 39 times 39 over 39. So again, 139 cancels out. You get 39 equals 39. That means it's a solution for every single value of c. So that just confirms that D is the correct answer. Again, this is back solving. This is honestly probably seems more complicated, more complex than the initial method I did using algebra. Now, here's how we could do this using Desmos. So let me clear the screen, bring up the calculator, expand it out. All right, so basically what I'm going to do is I'm going to graph the left side and I'm going to graph the right side. Now to get the square root, we have to go down here to the keyboard. And I'm going to use a slider for c. Okay, for right now, we'll just let it equal to 1. So there's the left side. Here is the graph of the right side. Okay, so we're looking for solutions to this equation. So when we basically do this, we graph both sides. And just zoom out here so we can get a better picture. There we go. So we graph the left side, we graph the right side, and where they intersect, where both sides are equal, those are the solutions to the equation. So now notice I set the C value equal to 1, and it tells us in the problem C is a positive constant, so that matches so far. So we have two solutions. Basically, we have like negative, let's see here, negative 39.013 and positive 39.013. All right, so plus or minus 39.013. So now what we need to do is take our value of C, which is 1, plug it into the answer choices, and see which answer choice matches one of these two numbers. So in the first answer choice, it would just be negative 1. Does that match, 39.013, positive or negative? No. Get rid of it. Second answer choice, C squared. Well, 1 squared is 1, so it's negative 1 minus 39 squared. Does that match? Does that equal 39.013? No, obviously not, but you could do it in Desmos just to confirm. Third one, we have negative square root 39 squared minus 1 squared. So this obviously you don't know, probably don't know what it is in your head. So you just go ahead and type it in. Okay, so this comes out to negative 38.987. That is close to 39.013, but it is not the exact number. So this is wrong. Now we'll check the last one, and we've got 1 squared plus 39 squared added together under a radical. So I'm just going to go back here. Get rid of this. Okay, now we get our answer, negative 39.0128, and notice if I round it off, it rounds off to 0.013. So so therefore D is the correct answer. This confirms it. And again, all I did is I entered both sides of the equation. I picked a value for C. I looked at what the solutions were on the graph in Desmos, and then I plugged that C value into the answer choices to see which answer choice gave me the same solutions that the graph in Desmos did. So again, correct answer, letter D. All right, now let's take a look at the very last problem, 22 on the module, this section 2, the math, module 2B, the harder module. So for this question, you are given basically the standard form equation for a quadratic function. You're given some information about it, that it opens upward. So of course that means a has to be greater than 0. You're also told that f of 9 is equal to f of 3. So in other words, when you plug in negative 9 and you plug in 3, you get the same y value as your output. And you're also told that k, the y coordinate of the vertex, is negative. Okay, so they want to know which of the following must be true. So first thing I'm going to do is I'm going to try to figure out the value of a. And there's technically two ways you could do this. The easy way is to use the shortcut formula that h, or the x-coordinate of your vertex, is equal to negative b over 2a. Now, we know that b is 4. We don't know a. That's what we're solving for. So we got negative 4 over 2a. But here's the other thing we know. In a quadratic function, the vertex is basically the center point in terms of symmetry. So in other words, you have a graph of a quadratic function, and if the f of 3, in other words, when x equals 3, let's say 1, 2, 3, if that y value, which just in my example it's 0, it doesn't have to be, is equal to the same y value that you get for negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, that means these points are symmetric with respect to the vertex, i.e. the vertex is directly in the middle of them. So the way you find the x-coordinate for the vertex is you just take the 2 points and you find the average of them. Just add them together, divide by 2. So you do that, you get negative 6 over 2, which is just negative 3. That means the value of h in this for this quadratic function has to be negative 3. So now you can set this equal to negative 3, and you can just solve for a. So if we just first notice the 2 goes into 4, two times. So we have negative 2 over a equals 3. Cross multiply, negative 2 equals 3a. Divide by 3. A equals negative 2/3 for this specific quadratic function. Therefore, must it be true that a is greater than or equal to 1? No, it must not be true because we just found that a has to equal negative. Uh, wait, sorry, I made a slight mistake here. This should be negative 3. A is actually equal to positive 2/3. This is negative 3. Sorry, this is negative 3, negative 3, negative 3. Negative 2 divided by negative 3. Sorry, it's positive 2/3, not negative 2/3. But regardless, it's still not greater than or equal to 1. Okay, so number 2 does not have to be true. In fact, it's false. So we get rid of this, and we get rid of this. Okay, we're down to now either 1 is true or none are true. So it's either A or D. All right. So just before I move on, also, just to show you an alternate way you could get this as well. Let me just clear the screen. Again, these answer choices are already eliminated. An alternate way that you could actually get it too is you could plug in the x values and set the two equations equal to each other. So for example, if you plug in negative 9 and then you simplify it out and you plug in 3 and you simplify it out, uh, notice what's going to happen is the c's will cancel out because they're the same on both sides. You get 81a minus 36 equals 9a plus 12. And then you go ahead and solve that. You get 72a equals 48. Divide by 72. And you get a equals 2 over 3. So that's just an alternate way you could figure out the value of a if you did not know the shortcut formula or forgot it or didn't realize you could apply it. Again, I've plugged in the x coordinates that have the same y values, negative 9 and positive 3, and then I set those two equations equal to each other because we know that f of negative 9, which is what this is equal to f of 3. Okay, so regardless, a is 2/3. It does not have to be greater than or equal to 1. Now, the question is, what about the c value? So I found that the easiest way just to confirm that 1 is actually not going to be true, the correct answer for this is going to be D, is to go to Desmos and graph it out. Okay, and so here is the easiest way, basically, I think, to do that. Just clear the screen temporarily. So if we go ahead and we graph this function, okay, and we're going to use a slider for C. Now, all we need to make sure is that the k value, the y coordinate of the vertex, is negative because it tells us in the problem, right here, it says if k is less than 0. So all we need to make sure is that our vertex point has a negative y coordinate, i.e. is below the x-axis. So, if I look at my graph here, it says which of the following must be true? C is less than 0. So right now, does C have to be less than 0? Well, it's true that if C is less than 0, then yes, the k value is negative. But if I make it greater than 0 or even equal to 0 itself, so right now C is equal to, get rid of this, C is equal to 0. So notice this meets all the criteria of the problem. And if you go ahead and you increase it from 0, basically, really, C has to be less than 6 in order for the k value to be less than 0, for the vertex to be below the x axis. So does C have to be less than 0? No, we found multiple instances where C is greater than 0, anything basically from 0 up to 6, just less than 6, where it meets the given criteria of the problem. The vertex is below the x-axis. So 1 is not true. Therefore, correct answer to this problem, like I said, it's going to be D. neither of them have to be true in order to meet, um, basically all these given conditions that they give you in the problem. All right, so that was again module two of the practice test two, math section, the harder module, module 2B. So if you have any questions, comments, or concerns, please do feel free to leave them below. Of course, if you like this video, please do give it a thumbs up and subscribe to my channel, sign up for notifications. Otherwise, be on the lookout for solutions to the rest of the digital SAT Blue Book practice tests.